All right, welcome back, fourth grade math teachers, as we get you ready for another week of amazing fourth grade math content. Welcome back to another prep talk. This video will help you get ready for your PLCs the week of October 10th so that you are ready and prepared to teach that content October 17th through the 21st. So thank you so much for joining us, and let's jump right in. We're going to be sticking with TEK 4H and 5A this week, finishing up talking about multiplication, problem solving using strip diagrams and equations, and then move into the idea of division. And so we'll start on Tuesday representing the quotient of a 2-digit by a 1-digit using base 10 blocks. Then we'll move into a 3-digit by a 1-digit using base 10 blocks to build that conceptual understanding of this idea of division. And then on Thursday, we'll come back to that area model that we used to multiply a few weeks ago and talk about how we could use it to actually represent a quotient of a 4-digit by 1-digit number. Friday is a flex day, and so if you need more practice on one of these skills or would like to give a CFA over what you have learned this week, Friday would be a great opportunity to do that. And I just want to remind you that on our district checkpoints, we use new questions. We write new questions on those district checkpoints. And so you are more than welcome and in fact encouraged to use the star released questions on your CFA, because that will give you great information about if a student is on track to be a master of the standard that they are learning. And so again, on Monday, we will be finishing up TEK 4, 5A, and 4.4H as far as multiplication is concerned, and then be moving into division. Then we will finish the week off by learning our first strategy for TEK 4F of dividing up to a 4-digit dividend by a 1-digit divisor. You'll notice that if we want to count wins for the week, our wins are going to be based on TEK 4H that's been tested 9 times and 5A that's been tested 8 times in the last 5 years. And then as far as supporting standards go, 4F is a pretty frequent flyer, having been tested 3 times in the last 5 years. 4E has only been tested 1 time, and that was as an equation back in 2021. As we look at this released item, we see that this is representing a multi-step problem based on the answer choices. It looks like it's 3 steps involving perhaps any of 2 of the 4 operations. I can see that in F, there's multiplication and addition, G is division and addition, H is multiplication and subtraction, and J is multiplication and addition. And so I'm really going to have to immerse myself into the story of this problem, close my eyes as it's being read or as I read it, really think about what's going on, and reading comprehension will be a big deal when we are trying to answer a problem such as this. The other thing that's really going to help is if students are able to draw a strip diagram like the one that I've shown. And I'm going to show you where all of the parts come from this. And then in the next slide, we'll talk about how we could teach kids to be able to draw this for themselves. What we see in this problem is that each Saturday, Mr. Franklin teaches 3 piano lessons at his music school and 4 piano lessons in students' homes. For each lesson at his music school, he charges $15, and for each lesson in a student's home, he charges $20. And we want to know which set of equations is used to find the amount of money that Mr. Franklin earns from piano lessons every Saturday. So what I notice here in my strip diagram that I drew is that I have 3 boxes that have 15 in them, and that is because for each lesson at his music school, Mr. Franklin charges $15, and he does 3 piano lessons at his music school. And so that's why we have 3 boxes of $15. And if we're adding all of this together to get the total, one way to start off this would take that $15 and multiply it by 3. That, of course, would give me 45. And so that would be what we get for these 3 boxes right here. We then go on to see that for each lesson in a student's home, Mr. Franklin charges $20, and that he gives 4 of those lessons in students' homes each Saturday. And so that's why we have here the 4 boxes that all have a 20 in them. And so in order to find the total from the lessons that Mr. Franklin gives in a student's home, we would multiply 20 by 4, which would give us 80. Now, those are the first 2 steps in order to solve this real-world problem. If we look at our answer choices, there are 2 of them that have those in there. H and J both have 15 times 3 and 20 times 4. H, in order to find the total, has a student subtracting 80 minus 45 in order to find the total, and J has the students adding. And what I can see from my strip diagram is that I'm looking for the total, and I'm going to add up the parts in order to get that whole. And so J would be the correct answer in this particular case. In the next slide, we'll talk about how to break this problem apart into teachable and learnable steps for students to be able to put it all together. Some curriculum resources to help you teach students how to model problem solving using multiplication are Engaging Math, page 143. You will model the second problem for students, with the key being on page 142, and then the Name It activity that is in the curriculum resources as well. This will really have students dissecting the different parts of how to do this, including drawing the strip diagram and indicating what each number in the equation is representing. You can see that in the Name It activity, we have the 3 equations that are associated with this 3-step word problem, just like the star released question we just looked at, and students have an answer bank that they can use in order to fill in the bubbles. This is a great thing to do during your problem-solving block at the beginning of each lesson. You have 10 to 15 minutes every day where you can continue to think about problem-solving strategies and throw these multi-step problems where students have to draw a strip diagram, set up the equations, and then think about how they would solve the problem. You don't have to always work one problem a day. Sometimes you can spend an entire week on a problem, and as long as you are drawing out different aspects of that problem each day, that can be a really beneficial time for students as they build their problem-solving skills. So as we look at this released question, this is again a 3-step problem that students will have to model this time using a strip diagram. And so if we look at this, we see that Alexa had a total of 36 bottles of water. Well, students have been doing strip diagrams and part whole mats really since the 1st grade, and we have always taught them that the total goes either at the top or the bottom and encompasses the entire diagram. If you look at our answer choices, it looks like 3 satisfy that requirement. B, C, and D all have the 36 as the whole or as the total. Letter A does not have that, and so we can eliminate it as a possible answer. Reading the second sentence, we see that she drank half of the bottles of water last week, and so we should see our strip diagram separated into 2 halves. Well, C and D check that requirement, but B certainly does not, and so that one is now going to be eliminated as well. Then we are told that Alexa will drink the remaining water bottles during the next 6 days, and that she will drink the same number of bottles each day. And so the remaining water bottles will be separated into 6 equal days, and we see that C is the answer choice that accounts for that 3rd and final step. And so letter C would be the correct answer here. But you can have students digest each of the answer choices and discuss, why is it not a good answer choice? Why does it not fit this particular problem? For letter A, we could talk about the fact that 36 is not the total. We could also talk about the fact that this is not separated into 2 equal parts or halves. Then we could say here for B, again, this is not separated into 2 equal halves. And then that D does not account for the fact that she will drink the remaining water bottles during the next 6 days, and that we want to know how many she is drinking in each of those days. As we turn the corner to Tuesday and begin talking about division of 2-digit by 1-digit numbers using base 10 blocks, I cannot recommend highly enough the script that you have available for you in your Math in Practice book on pages 116 through 119. This lays it out beautifully for you on how you will teach this using 2-digit division. And then you can extend it on Wednesday when talking about 3-digit by 1-digit division. We'll see that the Math in Practice will start with this particular problem where students will be breaking up 39 students into 3 equal groups. And so if you have students start with 3 10s and 9 1s in base 10 blocks, they need to be able to separate those into 3 equal groups. And so what they'll see is that each group is going to get one of the 3 10s. So how does that connect to the standard algorithm whenever we get to that point? Well, we would have students write the divisor on the outside, the dividend on the inside, and what we're asking here when we do this algorithm is if we have 3 10s, which this is 3 10s, and we want to put them into 3 groups, how many can we evenly distribute into each of those 3 groups? And the answer is that we can put 1 10 in each of those 3 groups. Then, when we multiply and subtract, that gives us the number of 10s left over. Well, we don't have any 10s left over because each of these 3 10s got put into a group. And so we don't have those anymore, and we don't have any left over. Then we do the same thing with the 1s. We drop down that 9, which is in the 1's place, and we ask ourselves, if we have 9 1s, how many can we put in each of 3 groups? And so as students are sorting this, 1 goes there, 1 goes there, 1 goes there, 2 goes there, 2 goes there, 2 goes there. Eventually what they notice is that we are able to put 3 in each of those groups, and that when we do that, we don't have any of the 1s left over. And so that's how we end up at the result by noticing that each group has 1 10 and 3 1s for a total of 13. That's how you'll start off in this Math in Practice, and in the next problem we'll see where students might need to regroup something. After students have had sufficient time to digest the first problem and you have used talk moves such as saying more to get more of a response or having students agree or disagree with their friends on what they say, then move into the second problem. Jill is putting pictures in a photo album. She has 52 pictures and wants to put the same number of photos on each of 4 pages. How many pictures will be on each page? And so we're trying to take that big total of 52 and distribute it into 4 equal pages. So what we want to start doing is just what we did on the last problem, starting with our 10s and distributing those. That group will get 1 10, this group will get 1 10, this group will get a 10, and this group will get a 10. But then I have 1 10 left over, and I'm not able to equally distribute the rest of the 10s to all of my 4 groups. And so this will be the roadblock that students run into, and you want to not discourage your students, but certainly allow them to engage in some productive struggle. And the Math in Practice book will give you some leading questions that you may be able to use for students to get on the right track and begin thinking about the possibility of regrouping that 10. And so once they get to regrouping, they can take that 1 10 that's left over and regroup it as 10 1s. And I'm using dots as my 1s just because it's a little bit faster than drawing 10 boxes. And so now what they notice is that they have 12 1s remaining, and those can be equally distributed amongst the 4 pages if each of the pages gets 3. And so that will be the revelation on this problem, is that we can actually regroup and then continue in the division process. How does this connect to the standard algorithm? Well, if we want to do 52 divided by 4, we begin by looking at the tens place. We have 5 tens and we want to put them in 4 equal groups. That means that each group is going to get one of those tens, and that number will go above the tens place in order to indicate that. Once we do all of that work, it's going to leave us with 1 10 left over. But we can't distribute that 1 10 among 4 equal pages, and so we have to regroup it as ones and then add it to the ones that we started with, which were the 2 ones here, and that's what happens when we drop down that 2. That's where we got the 12 ones in the base 10 block process, and then we decided that we were able to group those 12 ones equally into the 4 pages if we put 3 ones on each page. And so that's how we ended up again with the answer of 13, which we can see from each of our 4 groups. Moving into Wednesday, we'll begin talking about representing 3-digit by 1-digit division using base 10 blocks. Here is one of the questions that you have in the curriculum resources. How many cars are needed to transport 119 passengers if each car can hold 5 passengers? Write your equation and solve. And so what we would want students to do is, first of all, write down their equation, which would be 119 divided by 5. You could also front load the standard algorithm if you wanted to and have them think about how would we write that in the standard algorithm, 5 being divided into 119. Students will start with 119 base 10 blocks and start distributing those. They'll immediately realize that they cannot equally distribute their hundreds, and so they will have to break that up and make it 11 tens. 11 because we have 10 from the 100 and then the 1 that we also had right there. And so if we are taking 11 tens and breaking them up into 5 equal groups, then that means that each group is going to have 2 tens. Then from there, we would just continue the process and have 4 left over. And so this is sort of the first opportunity for you to talk about remainders and interpreting remainders. What we're going to see here by doing this problem is that the quotient is 23. But remember that the question was how many cars are needed to transport 119 passengers. Those 23 cars are going to be good to transport 115 of my passengers, but what about the 4 that we have left over right here? We're going to have to add an additional car so that it takes us 24 cars in order to get our passengers transported to where they need to go. We can follow up with additional questions about this real-world context so that students are able to interpret both the quotient and the remainder in this problem. For example, as we did 119 divided into 5 groups, how many full cars did we get? Well, that would be the quotient, 23. But what about in that last car, that 24th car that we said we're going to need in order to transport all of these passengers? How many passengers are in that last car? And that's where the 4 that were left over come into play. And it might be helpful to remind students that we started with 119. 119 what? That's right, 119 passengers. So that means when we were unable to sort the remaining 4 equally into the equally 5 groups, that those leftovers represented passengers that would have to get a 24th car in order to be transported successfully. As we move into Thursday, we begin to introduce the strategy of using the area model to divide up to a 4-digit dividend by a 1-digit divisor. Let's look at the following released question. A teacher put 378 marbles into 9 containers. He put the same number of marbles into each container. And we want to know how many marbles the teacher put into each container. Before students begin solving the problem, they need to have a discussion about what operation will be used in order to answer this question. We are trying to put 378 marbles into 9 containers, putting the same number into each container. And so we're trying to distribute the 378 into 9 groups. And so this is a division problem. Students need to be able to read it, comprehend it, and then make the decision that this is in fact division. And so we are trying to solve the problem 378 divided by 9. Students are familiar with using the area model for multiplication, so you may try to relate this to the familiar relationship of the multiplication equation. 9 multiplied by what would equal to 378? Well, if that's the problem that I'm trying to answer and I'm using the area model, then I know that one of my factors, 9, is going to go on the side, and then my product that I'm hoping to end up with, 378, is going to go on the inside. And we are looking for the other factor that would give us 378 whenever we multiply that factor by 9. And so the way that we're going to do this is by chipping away at that 378 little by little. And so we'll start by writing our total over here on the right and start finding numbers that we can multiply 9 by that will slowly but surely chip away at that 378. And so maybe we start with 10. We'll be super conservative because we know that 10 times 9 is 90, and we know that 90 is less than 378. And so if we subtract the 90 from 378, that's going to give us 288. And so we would keep going with this process. We know that we were just able to do 90. Well, 90 times 2 is 180, so maybe we can try 20 here instead and get a little less conservative and a more aggressive in chipping away at our total. And so 9 times 20, I know how to do that. That would just be 180. 9 times 2, and then times 10. And so now I'm going to take away 180 from my remaining total, which is going to give me 108. From there, I can see that I'm going to have to keep going here, and I could take another 90 away. And so if I, again, multiply 9 times 10, that's going to give me 90. And so I can take, again, another 90 away here, which will give me 18. And so I have 18 remaining. I need to figure out what I can multiply 9 by in order to get 18. And since I know the basic multiplication fact that 9 times 2 is 18, that is going to finish it off here. I'm going to be able to subtract 18. I'm out of room there, so I'm going to have to do it up here on my screen. 18 minus 18 will give me 0. And so now, in order to arrive at my answer, we're going to add all of these factors that are up here on the top. 10 plus 20 plus 10 plus 2 is going to give me 42. One thing that you'll want students to verify is that the numbers inside of our area models add up to the dividend. And so if we add up the numbers inside the boxes, we're going to wind up with 378 as our dividend. And so that leads me to the equation 378 divided by 9 is equal to 42. One thing you can have students do is multiply this out in order to verify their answer. They should end up with 42 times 9, which will arrive them at the original dividend of 378. This is a great strategy to have students find a different way to do it. Maybe you have students that start with 30 on the top of their area model. Maybe you even have students that go as far and start with 40 as their area model. More than likely, as students begin to start out, they will remain conservative and start with 10 or something small. But as they get more comfortable, hopefully you'll start to see them become a little more aggressive, and that will cut down on the amount of work at chipping away at their answers. This problem gets up to a 4-digit dividend by a 1-digit divisor. Again, you're going to want to do this in a problem-solving setting so that students are having to think through and talk through what operation are we going to use in order to answer this question. We have 1,092 people who work in an office building. The building has 4 floors and the same number of people work on each floor. And so we are trying to distribute the 1,092 into 4 floors that have the same number of people on each floor. And so again, we will be dividing 1,092 by 4. Using the area model, we know that we'll have our factor 4 here on the left, and we want to try and figure out how we can multiply in order to get up to 1,092. As we were saying in the previous problem, hopefully students will get more aggressive as they get more comfortable with this area model. And so instead of starting off with 10 here, which would only get me to 40, maybe they start thinking about how we can more aggressively chip away at 1,092. Maybe they realize that we could start with 100, and that would get us to 400, which would pretty significantly take away from that 1,092. That would be a pretty good place to start. Or maybe they realize that if we multiply by 25, that would get us to 100. And then if we multiply by 250, that would get us to 1,000. And so that's a good starting place here for this particular problem. If we take away the 1,000 over here, that's going to leave us with 92. Well, what could we multiply 4 by in order to chip away at 92? Maybe students realize that 4 could go into 90 20 times. And so if I multiply 4 times 20, that will give me 80, and I will be able to significantly take away from that remaining total of 92 and be left with 12. Finally, we need to figure out what will multiply by 4 in order to give me 12, and we know the basic multiplication fact that 4 times 3 is going to give me 12. Once again, in order to find our quotient, we're going to add the factors on top of our area model, which will give us 273. And we want to verify that when we add up the numbers inside of our model, that it ends up at our original dividend. And in this case, it does, 1,092. Again, students can verify their answer through multiplication. That 273 multiplied by 4 does in fact equal our original total of 1,092. And so F would be the correct answer in this case. If you have any questions about the concepts that you'll be teaching this week, please feel free to reach out to me or to our 3 through 5 math facilitator, Sherry Height. Our email addresses are listed here on the screen, and we would be more than happy to help you through any questions that you have, either on the content or the curriculum resources that are available to you in Eduphoria. And as always, before you go, please fill out the survey using the link or the QR code to the left. This will let us know that you watched the video, allow you to ask any questions, and help us to serve you better in future videos. Thank you again so much for watching, and please let us know if you have any questions as we hope that you have a great week with your students in math.